Hello everyone. Today we'll be discussing about the transformers. I am Dr. Amrita Sinha and we are going to start the discussion on the transformers. So what we'll be discussing in this topic is the definition of a transformer, broad classification, the major type of the transformer classification is as core type and shell type, and construction of the power transformers, which you can see in your nearby locality. What is a transformer? A transformer is a static device. This means no moving part is there like any other machine. Its working principle is based on Faraday's law of electromagnetic induction. The power is getting transferred from one electrical circuit to the other electrical circuit without any change in frequency, with or without change in voltage, with electrical isolation. So how we define it is, a transformer is a static device, electrical device, which by the principle of electromagnetic induction transfers electrical energy from one electrical circuit to another without any physical connection and without changing its characteristics like frequency and phase. The energy transfer usually takes place with a change of the voltage and current. Transformers either increases or decreases AC voltage. Because we all know the transformer being a static electrical device, the efficiency is very high, above 95%. Because transformer is a static device, so the rate of change of flux is not possible by the movement. Hence, the input itself has to be a variable quantity, and therefore the transformer works on only AC and not DC supply, because AC gives you a constantly varying quantity, and therefore the flux is also a variable quantity, mostly a sine waveform, and therefore you have got the electromagnetic induction principle being applied, and the electrical energy is transferred from one electrical circuit to the other circuit with the help of the mutual coupling between the two coils, primary coil and the secondary coil, or the input side and the output side, without any physical connection between the two coils. So when there is no physical connection between two coils, that is known as the electrical isolation. Now we'll try to classify the transformer based on different elements. On the basis of input and output voltage, the transformer is classified as step-up transformer and step-down transformer. Step-up transformer means that the output voltage is more than the input voltage, and step-down transformer means the output voltage is less than the input voltage. On the basis of construction, we have core type transformer and shell type transformer, which will be discussed later in detail. On the basis of the supply system, the AC supply is mainly of two types, single phase supply and three phase supply. Single phase supply, you can find it in your labs, single phase variac, that is also a transformer, or in electronic circuitry, small transformers you will find it out. The three phase is normally used in our generation, transmission and the distribution side, because where the bulk power is being transferred, there you need a three phase transformer. Then on the basis of the cooling applied, because in the large transformers the heat generated is quite high, and therefore we should have a proper methodology of cooling the windings. So air cooled, smaller size, just the ambience of the temperature or the ambient temperature helps in cooling down the actual transformer, while when the rating increases, the oil is filled in the tank and the oil serves the purpose of cooling of the transformer winding due to natural circulation of the oil. And if the size is still bigger or the ambience is not that cool, then we have to go for the oil cooled, water cooled type. That is, the oil pipes have got a water jacket and the water is circulated through pipe so that the oil gets cooled up faster. Then the last one is on the basis of the use or application. We have got power transformers. Power transformers are normally at the generator end. That is where we generate the bulk power using turbo generators or hydro generators. And after transmitting it, where we again need to step down the voltage. So at the grid station or the substation, we use the power transformers. Distribution transformers are a bit smaller rating than the power transformers. It's only used in the distribution network. Maybe you can find somewhere near your locality from where you get the supply. That will be a distribution transformer. Normally the distribution transformer size is in few kVAs, while the power transformers may be in few MVAs. Then the last one is the instrument transformer, used for the protection purpose and the metering purpose. Instrument transformers are normally installed in any of the substations, grid stations, generating stations, mainly to protect the actual system, not at a higher level of the voltage and current, but a lower level of the voltage and current. So current transformer helps in lowering the current to the 5 ampere or 1 ampere level, and potential transformer reduces the voltage to 110 volts so that we can have a standardization of the relay and the meters being installed. Now this is the way we represent the transformer. Actually, this is not placed like this physically, but to have the analysis purpose or to have the try to understand how is the working of the transformer, we represent the transformer in this form. The rectangular section is the core of the transformer. The vertical side is known as the limb, and the horizontal ones are known as the yoke of the transformer. So the core has got two parts, limb and the yoke. The flux is being produced in the core of the transformer, and that flux links both the primary winding and the secondary winding. The coil shown over here, the primary winding, the input side is known as the primary winding and the output is known as the secondary winding. But it can be used as a vice versa, that is high voltage or the low voltage side, or from the low to the high voltage side. Basically from wherever we get the input, that is known as the primary, and from wherever we take the output, that is known as the secondary side. Now mainly transformer consists of the magnetic circuit, electrical circuit, dielectric and tank and accessories. Magnetic circuit is which provides the path to the flow of the magnetic flux, consisting of limb, yoke and the clamping structure. That is, this core is not made up of a solid section. There are multiple sections which is being used to make the core cross-sectional area, and to put them together we need some clamping structure. That is what completes the magnetic circuit. Electrical circuit, it consists of two windings, that is the primary and the secondary windings, usually made up of copper and insulated from each other as well as from the steel core. The copper wires used is normally varnished and insulated, which is known as the super enameled copper. Basically there is an insulating coating over the bare copper, and from the core to the winding again some insulation has to be provided. That may be paper, mica or some cloth, depending on the level of the voltage where we are using the transformer. Therefore there are variety of the dielectrics being used, which is known as the dielectric circuit, between the windings, between different layers of the windings, between the cores and the core and the winding. So there are multiple dielectric materials being used in the transformer. Then the main transformer is being put into a tank with the accessories to facilitate the working of the transformers. Those are known as the tanks and the accessories. The core of the transformer is constructed by assembling or stacking varnished laminated sheets of steel with minimum air gap between them to achieve continuous magnetic path. The steel used is having high silicon content, 3 to 4%, to provide high permeability, low hysteresis loss, and high resistivity. Thin laminated sheets from 0.3 to 0.35 mm are normally used to reduce the eddy current loss. The sheets are either hot rolled or cold rolled, that is CRGO. Sheets are cut in the shape as E, I, U, C, L. To avoid high reluctance at joints, laminations are stacked by alternating the sides of the joints. Now in the figure we can see that instead of having a solid core, the thin sheets are being used to make a cross section of the area of the core. The thin sheets of these material or this metal basically is used to reduce the eddy current, that is by increasing the resistance of the solid material, the eddy current can be reduced, because if the resistance of the path increases, naturally the current will reduce. So to have those thin laminations, it is due to the reduction of the eddy current losses. You want to reduce the eddy current losses, hence thin laminations are being used. To make these thin laminations, you add the silicon content so that it increases the permeability and it has got low hysteresis loss. But if the silicon content is very high, the material will become brittle and these thin laminations can break. Hence, the silicon content is limited to 3 to 4%. Then, because the core is made of multiple sections, hence the air gap needs to be distributed throughout the stacking of the material, because if the air gap is at one place, it will have a uniform air gap distribution, and the MMF required to build the same flux will be much more, because the reluctance of the path will increase due to the uniform air gap. So we distribute the air gap such that the reluctance of the path is kept to the minimum and the flux can be produced by a small MMF. These are the multiple type of sections which we use for the construction purpose. C section, then alternately instead of the vertical air gap, we'll have the horizontal air gap. Next, C and I section, the left side, right side you have got it. Then in the next step, we can put it on the left side. So right, left, the uniform air gap can be distributed. L2 L sections, we can just rotate by 90 degrees and rotate the air gap so that it is uniformly distributed. Then EI section, one side, E and I. So next surface, the I will be on the left side, E will be on the right side, and so on. Basically, it is to not have the air gap at one place. So that's the reason we keep on changing. Now the windings of the transformer, there are two types of winding normally being used for the transformer: cylindrical or the concentric winding, and sandwich or the disc winding. But we use mostly the copper material only to make the windings of the transformer instead of the aluminium, because aluminium requires a larger cross-sectional area to carry the same current. Now this cylindrical or concentric winding is placed one on top of the other around the core. LV winding or the low voltage winding is normally kept near the core, and outside is the high voltage winding, just to provide a better insulation for the high voltage coils. Now, the next is your sandwich and disc winding, because they look like a one layer after the other. So you can say it's a sandwich of the different discs, and these discs, if you see, you have got LV, HV, LV, HV, alternately it has been placed, but one which has been placed on the top is only the half winding and the remaining half will be at the bottom, so that the flux is equally distributed between the windings. Then we have got the major two types of classification, that is the core type and shell type of transformers. In core type of transformer, the primary and the secondary windings are wound outside and surround the core ring. The cylindrical coils mounted on the core limbs have different layers, and each layer is insulated from each other. Materials like paper, cloth, and mica can be used for insulation depending on the voltage level. Low voltage windings are placed nearer to the core so that they can be easily insulated, and HV, if it is placed outside, the greater insulation can be provided to those windings. In shell type of transformer, the primary and the secondary winding pass inside the steel magnetic core, which forms a shell around the windings. That means the core is, it looks like that the core is protecting the winding. Hence, the core acts like a shell to the winding, and the name given as shell type transformer. The coils are former wound and mounted in layers stacked with the insulation between them. Now, as per the figure, you can see what is the difference between the core and shell type. In core type, on both the limbs, you have the windings being placed. So the core is inside the winding, the coils can be seen from outside, and the core is inside those windings. While in the shell type of transformer, the winding is inside the core. It is surrounded by the core. So from outside, you can see the core and not the winding properly. And that's the reason it's known as the shell type of construction. Now here you can see single phase and three phase transformers, core type and shell type. Now core type, you can see the core is inside, the winding is wound on it. And in the shell type, on the central limb, the windings are being placed so that on the outer side, you have got the core, which acts as a protection layer to the winding. Now this is the practical transformer. Again, this is a core type of transformer. As you can see, the core is not at all visible. The limbs are not at all visible. The yokes are visible. But the winding is being placed over here of the transformer. And on the top, what you see, the brown color, and the top of it is the connectors and the bushings. Bushings depends on the voltage level. And the connectors are provided to have an external connection with the transmission system or the distribution system, wherever it is placed, to make electrical connection there. Now this particular transformer or this type of transformer is placed in a tank for the actual power transformer or the distribution transformer. Inside this tank, you have got the transformer, and this tank is filled with oil for two purposes, cooling as well as the insulating purpose. So that if any person who touches the tank should not get a shock. So the material what is being used between the winding and the tank should be having a good insulating property. Plus the oil is a petroleum product, so that provides the cooling of the windings also. Whatever oil is there near to the winding, that gets heated up fast, and so once it gets heated up, it tries to rise, and through these cooling tubes it goes outside. The ambient is cooler than the inside, so it gets cooled down, and once it gets cooled down, it enters from the bottom of the tank, and so there is a natural circulation of the oil due to the heating of the transformer oil, and the cooling tubes help in cooling of those transformer oil. So this natural circulation helps in the better cooling of the transformer. Because the tank is fully filled with the oil, so the extra, or to maintain the level of the oil, you have got a conservator on the top, and this conservator, as from the side we can see, it's only half filled with oil, it's not fully filled. That gives the space for the oil to contract and expand, because if the temperature is high, the oil expands, and therefore the conservator, the level of the oil in the conservator rises, while when the oil cools down or the load is less, in that case the oil contracts and it cools down and the level goes down. So when the level is changing in the conservator, when the volume increases, the air is pushed outside of the conservator through the breather, and when the oil cools down, it contracts, then the air is absorbed from the atmosphere. When you absorb air from the atmosphere that contains moisture, which decreases the dielectric strength of the transformer oil. Hence, to absorb the moisture, the breather is being used, and the breather is filled with silica gel so that it absorbs the moisture from the normal atmospheric air before it enters into the tank or the conservator. So it is the natural flow of the air from the conservator through the breather to the atmosphere. So it's known as the breathing of the transformer. Then we have got a temperature indicator. The temperature sensor is normally placed about 2 to 3 inches below the top level of the tank, because the oil is hottest at that position. So we can measure the highest oil temperature at the level over there. Hence, the temperature indicator is being used to know the condition of the transformer oil. If it is more heated, this means there is something wrong, some short circuit is there, therefore the oil is getting heated up. Then we have got a explosion vent. Explosion vent is a weak section being provided in the transformer, so that in case of any emergency, instead of the transformer getting burst, it can get a small weak hole from where it can come out. Because suppose there is some heavy short circuit inside the transformer, and there will be a lot of decomposition of the transformer oil, so that will build up pressure by the gas released, and that gas needs a escape vent, and that escape vent is provided with the help of the explosion vent. There are small thin diaphragm is there. In case of emergency, that diaphragm blows off and it gives a path for the inside pressure to be released. Then we have got the Buckles relay. Buckles relay is a gas operated relay placed between the tank and the conservator. If any type of fault which has just started to happen in the transformer, that produces heat, and due to that heat, the transformer oil decomposes, and that decomposed transformer oil releases gases, and those gases will try to escape to the conservator through the Buckles relay. So that Buckles relay traps the gas which is being released in the tank before it goes to the conservator, and by the level of the gas being released by the transformer can be analyzed for different purposes, and the relay can operate as an alarm in few situations and give a trip signal if the situation is serious or it has to be taken as a shutdown. These bushings we have already seen, which gives you a path, or it gives you a opening for the connection from the outside supply system, or to give the supply to the outside system. So those bushings are being provided in the transformer. So today we have discussed about the definition of the transformer, broad classification, core and shell type of transformers that is broadly being used as a classifier, and the construction of the power transformer, which is normally being seen in any nearby locality where you stay.